Our research topic will explore the average number of hours spent playing video games from BSD students compared to students in the US. Using the internet, our group was able to find a study on video game playtime from students ranging from ages 13 to 18. In this study, 1,677 respondents were randomly sampled and gathered through an online panel. Their responses reveal an average playtime of 1 hour and 36 minutes. We want to conduct a hypothesis test to see whether the statistic differs from a sample of BSD students. For our study, surveys were randomly distributed via social media platforms such as Instagram, Discord, and direct messaging systems. We limited output to people we are familiar with in the BSD who we know for certain are ranging from ages 13 to 18. We gathered 110 responses, however, 8 of these responses were removed as they were unrealistic/impossible portrayals of time, leaving us with 101 valid responses. Our hypothesis test will determine whether or not the 2019 statistic demonstrated on Statista.com differs from the sample of students in the BSD. Our population characteristic is numerical, as the responses recorded are measurements of time rather than percentages or proportions of a sample/population. Take, for example, a population proportion would be a percentage or a portion of a certain sample. However, a population mean would be a score, like a whole number.
For our null hypothesis, we have mu equals 1.6, where 1.6 represents the average time of 1 hour and 36 minutes in the Statista.com statistic for average amount of time played video games per day. Our alternative hypothesis is mu does not equal 1.6. We chose mu to represent our sample mean because our data's characteristic is numerical. For the formula, we used this one sample t-test formula because we weren't given the population standard deviation, and instead, we're given the sample population mean and the sample size is large. Specifically, it's 101. In this formula, t represents the test statistic, x bar represents the sample mean of 1.647, mu represents the population mean of 1.6, s represents the sample standard deviation of 1.804, and n represents the sample size of 101. To find our t value, we just used the formula from earlier and input all of our numbers. By doing so, it results in t equals 0.259251. Then, using the t-test option on the calculator, we can calculate our p-value by having mu of 0 represent the population sample mean, or the hypothesized value of 1.6. Our list inputted in the calculator represents our data from the sample. And for mu, we select does not equal mu of 0 because it's a two-tailed t-test. Doing so, we come out with p is equal to 0.795974, which means it is greater than 0.05.
Because our p-value of 0.795 is greater than alpha, we can conclude that with our data, we will reject the alternative hypothesis and retain the null hypothesis. This means that we cannot confidently conclude that the mean amount of time spent playing video games isn't 1.6 or 1 hour and 36 minutes every day, as that is the alternative hypothesis which we must reject.
Hey y'all, Eric here, and you know what comes after the conclusion? Errors.
Type 1 error is when you reject a true null hypothesis. It's like asking a girl out, then she rejects you.
No, please don't say no, we would make a great couple.
Type 2 error is when you accept a false null hypothesis. Like when you nail the job interview with fake credentials.
You know, I think we just might accept you.
The consequences of type 1 error in our situation is if we were to reject the true null hypothesis and accept our alternate hypothesis, when our alternate hypothesis is not true since mu is equal to 1.6. The consequences of the type 2 error is if our null hypothesis was false, or if our null hypothesis of mu equal 1.6 is incorrect.
Well, that concludes our project. I'm glad I won't have to do any more math after high school. I'm gonna be a science major. Wait,